Let's take a look at this question. 14th. Express the following expression in the form of a plus ib. What does the question say? It's a pretty complicated expression. We are supposed to convert this in the form of a plus ib. How do we convert this? Let's take a look at this. (14) is 3 plus I root 5, 3 minus I root 5. Now, can you observe this is a plus b, a minus b in the numerator? Yes. And they will multiply together. What we'll be getting is this is 3 square minus I root 5 whole square. Okay. What about the denominator? In the denominator, you have root 3 plus root 2i minus. It's not multiplication, it's minus. So let's simplify that separately. Minus root 3 and plus I root 2. That's what you observe, right? So root 3 and root 3 will get cancelled from the denominator. What about the numerator first? This is 9. I square becomes minus 1, 5, root 5 square becomes 5. Minus of 5 becomes minus or minus plus 5 in the numerator. In the denominator you get root 3 get cancelled. Root 2i and root 2i will be actually equal to 2 root 2i. Okay. And once you have an I in the denominator, we'll multiply with I in the numerator and in the denominator. Okay. And what does that give us? This is 14 upon 2 root 2 I square in the denominator, which will become minus 1, and there's an I in the numerator. Yes. What will this further simplify to? This will be equal to 14 upon 2 root 2 with a minus. So this is first of all minus. Okay. And 14 over 2 root 2. Let's multiply with a root 2 and a root 2 over here, so that denominator is also rationalized. Not leave irrational in the denominator, and you get this becomes 4. 14 upon 4 is actually 7 by 2 minus 7 root 2 by 2 I. And express this in the form a plus ib. Express it in the form a plus ib. This is 0 minus 7 root 2. Okay, this is a 2 in the denominator. Take care of this. 7 root 2 by 2i. This is 7 root 2 by 2i in the numerator. Sorry. The imaginary part is equal to this. And this is a plus ib form. Yes, this is a plus ib form of this complicated expression. And yes, that is my final answer for this question over here.